The ocean. A body of salt water that spans more than 70% of the globe's surface and makes up 97% of the world's water supply. Yet, more than 80% of the ocean remains unexplored, particularly in its depths. According to a 2017 article, The Deep Sea Under Global Change, less than 1/10,000% of the ocean's area more than 200 meters deep has been explored, meaning we know more about the moon's surface than the Earth's deep ocean surface. Although the deep ocean as we know it doesn't seem to be very interesting, as characterized by its low amounts of organic matter and a constant temperature around freezing point, what is stopping humans from exploring the depths of their own planet? One such reason is the human body. Normally, our bodies are adapted to an air pressure of 1 ATA, atmospheric pressure. But once someone dives to 33 feet, the ATA increases to 2. At this increased pressure, the lung size will shrink by half. With every additional increase in ATA, with every 33 feet, the lungs will continue to get smaller and smaller. If a human were to go into the depths of the ocean without proper equipment, a plethora of things could happen. But the two major issues are nitrogen narcosis, where at higher pressures, your body can absorb more nitrogen, and if you breathe too much, you can start to feel quite drunk, and decompression sickness, the bends, because if you rise too fast from the depths, instead of safely at the right rate, the nitrogen absorbed from the higher pressure can expand too quickly, leading to, in extreme cases, death. Even with the proper equipment, though, the human body can only handle so much. At sea level, the amount of pressure pushing down on your body is roughly 15 pounds per square inch. At the bottom of the Mariana Trench, the pressure is over 1,000 times more than that at the surface, which is the same as if you had 50 jumbo jets pressing on your body. The extreme depths also cause problems with the cardiovascular and nervous systems. For instance, in these depths, blood shifts out of your legs and arms into your chest cavity due to the changes in pressure. This enlarges all 4 chambers of your heart, making it do extra work to pump blood and increasing blood pressure. Heart rate drops in response, and the heart is strained as it pumps blood harder and faster to reach the constricted vessels and other parts of the body. With the nervous system, both the sympathetic and parasympathetic systems are affected. Non-stress dives result in parasympathetic responses, but stressful dives result in a sympathetic response. This increases chances of arrhythmia. The human body isn't the only limitation on deep sea exploration, though. Technology is as well. Of the vehicles used to explore the ocean floor, called submersibles as a group, the 2 most common are ROVs, remotely operated vehicles, and AUVs, autonomous vehicles. Most of the submersibles employed by NOAA, the National Oceanic and Atmospheric Administration, are able to dive between 4,000 and 6,000 meters deep, which includes most of the ocean area known as the abyss, or the abyssopelagic zone. Around 3/4 of the ocean is in this zone, according to a webpage published by NOAA. In this case, why do we know so little about the ocean floor? A big part of mapping the ocean floor is the use of sonar technology, in which a sound wave is released from a source on the submersible and is reflected back to it, where sensors pick up the wave patterns and can create an image of the seafloor. This sonar has its limits, though. The image quality of sonar decreases the deeper it is used, according to a publication by Andrea Cady in 1998. Another major limitation she describes is that the sound waves only return a strong signal to the sensor if the wave is perpendicular to the surface off of which it is reflecting. As a result, many data points are thrown away by the computer system because the data signal is too weak. This effect is amplified when the ocean conditions are rough. The last reason is money. Ocean exploration is expensive. According to an article written by Monica Wilson and her team, Year Undisclosed, operation of an ROV and AUV consists of $15,000 a day and $10,000 a day, respectively, not including the cost of operating the ship to launch or control the submersibles. Until we can find an economic incentive to rapidly progress the exploration of the ocean floor, the depths of the ocean will most likely remain in the dark. Though the human body and technology currently limit our exploration of the deep oceans, that should not keep us from trying to do so anyway. Who knows? Maybe you'll be the one to create a breakthrough technology, expanding our world as we know it to unimaginable lengths.